Good morning, my students. Today we will give you a video contains a summary for the whole lesson. Operations on limits. Let's start. First, we have taken two kinds of limits. The first one is to calculate limit of a function at a point. That means when x tends to number. The second kind is to calculate the limit of a function at infinities. That means when x tends to plus infinity or x tends to minus infinity. Also, we have learned how to calculate the limits at a point or at infinity for two kinds of function. What are them? The first one is for polynomial function and the second one is for rational function. What do we mean by polynomial function? Polynomial function is a function having the following form: p of x equals ax to the power n plus bx to the power n minus 1 plus constant, where the exponents n, n minus 1, etc. belong to set n. That means they are natural numbers. What do we mean by rational function? It is a function having the following form: f of x equals p of x over q of x, where p of x and q of x are two polynomials and q of x does not equal 0. Now we will start to review the limit at a point. That means as x tends to number. Concentrate. That means x tends to number. First, we will start when this function is a polynomial. If I have the following limit as x tends to 2 of the polynomial function x squared plus x minus 5. Directly, when we have limit as x tends to number, we will substitute this number instead of each x. So we will put instead of x squared 2 squared plus 2 minus 5, and we will get 4 plus 2 minus 5 to have the answer 1. If the answer is number, either positive number or negative number or 0, this is called determinate form and it is accepted. Let's continue. Now, if I have a rational function, for example, I have limit as x tends to 5 of the rational function x plus 1 over x minus 2, then we will substitute instead of each x by 5, and we will get 5 plus 1 in the numerator and 5 minus 2 in the denominators, and the answer will be 6 over 3, which is 2. Because the answer is number, then we call it determinate form and it is accepted. So we will now conclude that when we have limit as x tends to a number, then we will substitute instead of each x by number. Let's continue. Also, we will remember the following rule: any number that is positive over 0 plus, we will get the plus infinity, and a positive number over 0 minus, we will get minus infinity, and in general any number over 0, the answer will be plus or minus infinity. Now, if I have limit as x tends to 3 plus for the rational function x plus 1 over x minus 3, then I will substitute instead of x in the numerator by 3. I don't care to substitute in the numerator by 3 plus. I need it in the denominator. So I will get 3 plus 1 over 3 plus minus 3. 3 plus 1 is 4 and 3 plus minus 3 is 0 plus. And a positive number over 0 plus I will get plus infinity. And this is determinate form. Because the determinate form may be number or infinity, and the number may be plus, minus, or 0, and the infinity may be plus infinity or minus infinity. All these answers are determinate forms and they are accepted. Let's continue for another example. I have limit as x tends to 3 minus for a rational function x plus 1 over x minus 3. I will substitute 3 minus in the denominator because I care if the answer in the denominator is 0 plus or 0 minus. But in the denominator I don't care, so I will substitute by 3. To get 3 plus 1 over 3 minus 3, and the answer is 4 over 0 minus, and any positive number over 0 minus, the answer is minus infinity, and it is determinate. Now, what is the indeterminate form? If I have a rational function and I have x tends to number, then we may have indeterminate form, which is 0 over 0, and this form must be changed to what? Must be changed to determinate form, which is positive number or negative number or 0. So we will think by two methods. Do you remember them? How to change from indeterminate form to determinate form when x tends to a number? Let's see. The first method is to factorize, and the second method is to rationalize. Let's take some examples. First, if I have limit as x tends to minus 2 for the rational function x squared minus 4 over x plus 2, the first step is to substitute instead of x by minus 2. So we will get minus 2 all squared minus 4 over minus 2 plus 2. The answer is 4 minus 4 over minus 2 plus 2, and we will have 0 over 0. What is this form? Is it accepted and we will stop here? Sure no, it is indeterminate form and we will use one of the method, rationalize or factorize, to change it to determinate form. But here we don't have radical, so we will not use rationalize. Let's go to factorize. How to factorize this function? So, limit as x tends to minus 2 for the rational function x squared minus 4 over x plus 2, and we will use factorization, and now we will get what? We will get x minus 2 into x plus 2 over x plus 2. Remember that the cancellation is a very important step. So x plus 2 and x plus 2 will be cancelled, and we will have now limit as x tends to minus infinity of x minus 2. Now we can substitute instead of each x by minus 2 to get minus 2, and the answer is minus 4, and this is determinate form, so we can stop here. Now I will give you a simple example on irrational function. First, what do we mean by irrational function? Yes, it is a function that contains what? That contains radical. And under this radical, What do we have? We have a variable. So we called it a rational function. How do we find this limit? If I have limit as x tends to a number which is 0 here, for the irrational function radical x plus 1 minus 1 over x, first we will substitute instead of each x by 0, and we will get radical 0 plus 1 minus 1 over 0, and radical 1 is 1 minus 1 over 0. And the answer is 0 over 0. What do we call this form? Yes, it is indeterminate form, and we must change it to what? To determinate form by using what? Yes, either factorization or rationalize. But here we have a rational function that contains radical, so we will use rationalize. So we can say now we will have limit as x tends to 0 for this irrational function radical x plus 1 minus 1 over x, and we will rationalize it by multiplying this expression by the conjugate of the numerator, because the numerator is the term that contains radical. And now we will have limit as x tends to 0 radical x plus 1 minus 1, and the conjugate of the numerator is radical x plus 1 plus 1, and we will multiply by the conjugate in the numerator and in the denominator. So in the denominator we will have x multiplied by radical x plus 1 plus 1. And as you know, this represent for me the rule xa minus b into a plus b, which is difference of two squares and can be written in the form a squared minus b squared. To get limit as x tends to 0 is the square of the first term minus squaring of the second term over the denominator. And the square and radical will cancel each other to get x plus 1 minus 1 over x multiplied by radical x plus 1 plus 1. Now we have limit as x tends to 0 of x over x multiplied by radical x plus 1 plus 1. The most important step is to cancel x by x, and we will get limit as x tends to 0 of 1 over radical x plus 1 plus 1, and now we will substitute instead of each x by 0 to get 1 over radical 0 plus 1 plus 1, and this is radical 1, which is 1 plus 1 give me 0, and the answer is 1 over 2, and this is determinate form. We have finished till now the revision of the limits of a polynomial function and rational function when x tends to a point. And we have said that when we have limit as x tends to a number of a polynomial function or rational function or irrational function, first of all we will substitute instead of each x by this number. We may have determinate form that is number positive, negative, or 0 or infinity, and we will stop because it is accepted. But if I have indeterminate form that is 0 over 0, we must change it to determinate form by using factorize or rationalize. Now we will continue our revision by reviewing the limits of a function, either polynomial or rational, but when x tends to infinity. Let's start to calculate the limits of a function at infinity. First, if I have polynomial function, The golden rule is to calculate limit as x tends to plus or minus infinity of a polynomial function is the same as to calculate the limit as x tends to plus or minus infinity of the highest power term of this polynomial. Let's take an example. If I have limit as x tends to plus infinity of the polynomial function 2x squared minus 3x plus 2, because the limit is x tends to infinity, and take care it is as x tends to infinity of a polynomial function, then we will choose the highest power term, that is, yes, 2x squared, and we can write it is the same as limit as x tends to plus infinity of 2x squared, and we will substitute instead of x by plus infinity, and the plus infinity squared is plus infinity multiplied by 2, and the answer is plus infinity, which is determinant 4. The second example is to calculate limit as x tends to minus infinity of a polynomial function minus x cubed minus 3x to the power 4 plus 10x minus 1. Because the limit is x tends to minus infinity and this is polynomial function, then we can say that it is the same as limit as x tends to minus infinity of the highest power term, which is minus 3x to the power 4, and we will substitute instead of x by minus infinity to get minus 3 into minus infinity to the power 4, which is even, that it change this minus to plus infinity and multiplied by minus 3 to get minus infinity, which is determinant 4. Now, if I have rational function and we have limit as x tends to plus or minus infinity, if you remember, we have three cases. First, if I have the rational function f of x over g of x and f of x of degree m and g of x of degree n, and I want to calculate limit as x tends to infinity of f of x over g of x, where the degree of f of x is greater than the degree of g of x, then the answer will be infinity. And if I want to calculate the limit as x tends to infinity of f of x over g of x, and the degree of f of x is less than the degree of g of x, then the answer will be 0. And the last case, if I have limit as x tends to infinity of f of x over g of x and they have equal degrees, then the answer will be the ratio of the leading coefficient of f and g. And this will be very clear in the examples. The first example, if I have limit as x tends to minus infinity of a rational function 3x to the power 5 minus 2x plus 1 over 5x squared minus 2x cubed plus minus 3. Because we have limit as x tends to minus infinity and we have rational function of polynomial numerator and denominator, then we will use the highest power term rule. So we will get limit as x tends to minus infinity and the highest power term in the numerator is 3x to the power 5 and in the denominator is 2x cubed, to get limit as x tends to minus infinity 3x to the power 5 over 2x cubed, and we will cancel x power 5 and x cubed to get limit as x tends to minus infinity of 3x squared over 2, and we will substitute instead of x by minus infinity, and because this is even power, minus infinity will be plus infinity multiplied by positive number is positive infinity, and divided by 2 we will get the plus infinity, which is determinant 4. The second example, if I have limit as x tends to plus infinity of rational function 2x cubed plus 3x squared over x cubed plus 2. We have equal degrees and we will guess that the answer will be 2 over 1, which is 2. But let's see in the steps. So we will have now limit as x tends to plus infinity by choosing the highest power term in the numerator, which is 2x cubed, and the highest power term in the denominator, which is x cubed, and by cancelling x cubed and x cubed, we will get 2, which is determinate form. The third example is limit as x tends to minus infinity of a rational function 2x plus 1 over 3x squared plus 2x. Because the degree of the numerator is less than the degree of the denominator, we will guess that the answer will be 0. But let's continue our calculations. So we will have limit as x tends to minus infinity of the highest power term in the numerator, which is 2x, and the highest power term in the denominator, which is 3x squared, and by cancellation x and x squared, we will get limit as x tends to minus infinity of 2 over 3x, and we will substitute instead of x by minus infinity to get 2 over minus infinity, and any number over infinity, the answer is 0, and this is determinate form. Now we will go to asymptotes. What are the kinds of asymptote? Yes, the first one is the vertical asymptote, and the second one is the horizontal asymptote, and the third one is the oblique asymptote, and each one of them has a rule. What is the rule of the vertical asymptote? If I calculate limit as x tends to number of a rational function f of x, and I get plus or minus infinity, then this x will represent the vertical asymptote of equation x equals a. And if I have limit as x tends to plus or minus infinity of the function f of x, and the answer is a number, let's say b, then this number will represent for me the horizontal asymptote of equation y equals b. And if I calculate the limit as x tends to infinity and I get infinity, then we say f of x may have oblique asymptote. To be sure that this line is oblique asymptote, we will use the rule limit as x tends to plus or minus infinity of f of x minus the y of this line. If the answer is 0, then we can say that this line y of equation ax plus b is an oblique asymptote of this function. Let's see the examples. We want to calculate the limit as x tends to 2 of the rational function x plus 1 over x minus 2, then we will deduce the equation of the asymptote. First, we will substitute instead of each x by 2 to get 2 plus 1 over 2 minus 2, and the answer is 3 over 0, and any number over 0 is plus or minus infinity. Because we have limit as x tends to number and we get infinity, then this number will represent for me the vertical asymptote of equation x equal 2. Now, if I have limit as x tends to plus infinity of the rational function 3x over x squared plus 2, because I have limit as x tends to infinity, we will use the highest power term rule. So we will get limit as x tends to plus infinity, and the highest power term in the numerator is 3x, and in the denominator is x squared. And we will cancel x by x squared to get limit as x tends to plus infinity of 3 over x. Now we will substitute instead of each x by plus infinity to get the 3 over plus infinity, and any number over infinity is 0. If infinity gives me number, then this number will represent the horizontal asymptote as here. Because infinity gives me number 0, then this 0 will represent for me the horizontal asymptote of equation y equals 0. The second example, if I have limit as x tends to plus infinity of 3x squared over 4x squared plus 2, because it is rational function and we have limit as x tends to infinity, then we will use the highest power term rule. So we will have limit as x tends to plus infinity, and the highest power term in the numerator is 3x squared and in the denominator is 4x squared, and we will cancel x squared by x squared to get the 3 over 4. Because we have limit as x tends to plus infinity and we get number, then this number will represent for me the horizontal asymptote. Then the equation of our horizontal asymptote is y equals 3 over 4. Now the third example is about oblique asymptote. Let's read it. Given the function f of x equals x squared minus 1 over x minus 2, and we have the line D of equation y equals x plus 2. We want to prove that this line is an oblique asymptote of this function. As I have said before, that if the degree of the numerator is greater than the degree of the denominator by 1, then this line is surely representing the oblique asymptote of this function, but we want to prove it by using the rule. We have the rule limit as x tends to plus or minus infinity of f of x minus y of the line D. Now limit as x tends to plus or minus infinity, and we will substitute instead of f of x by its expression, which is x squared minus 1 over x minus 2, and we will substitute instead of the y of the line D by x plus 2. And as I have said, after minus you must open a bracket, and we must here have same denominators or like denominators. So we will put x plus 2 over 1, and we will have limit as x tends to plus or minus infinity of x squared minus 1 over x minus 2 minus x plus 2 in the numerator, and we will have like denominators, so we will multiply the denominator here by x minus 2 and here by x minus 2. Let's simplify. Limit as x tends to plus or minus infinity of x squared minus 1, and this is difference of 2 squares, that is x squared minus 4. And we have minus before the bracket, over x minus 2, which is the common denominator. Now we will simplify by entering this minus to the bracket to get limit as x tends to plus or minus infinity x squared minus 1 minus x squared plus 4 over x minus 2 minus x squared, and x squared is 0, and we will get limit as x tends to plus or minus infinity minus 1 and plus 4 is 3 over x minus 2. Now we will substitute instead of x by infinity to get 3 over infinity, and the answer is 0. Because the rule gives me 0 and it is true, then we can say the line D of equation y equals x plus 2 is oblique asymptote of this rational function. Now we will review the graphical exercises. I have this graph, the green curve is for a function f of x, and we have the asymptote. The blue one is the vertical and the red one is the horizontal. طبعا أنا عرفتهم من شكلهم ولأنه ال curve is very close to them at the ends. But let's start. We want to find the limit as x tends to 1 plus. 1 plus means to the right of 1. Let's go. Here 1, here we have 1 plus to the right and 1 minus to the left. First لما الطالب يشوف انه انا عندي على ال1 vertical line لحاله بده يعرف انه الانسر حيكون plus infinity or minus infinity. بس خلينا نشرحها اكتر. To the right of 1, here 1 plus, we will go to the place where we have the curve. here we have the curve very close to this line, and the curve, as you see, grows up and up to reach plus infinity. So when x tends to 1 plus the function f of x, then the answer will be plus infinity because the curve grows up. And when x tends to 1 minus, I mean by 1 minus to the left of 1. Let's go to the left of 1. This is the left of 1, and as you see, as x tends to 1 minus, the curve is going down and down to minus infinity. Look here. X tends to 1 minus, and the value of y is decreasing and become smaller and smaller to minus infinity. وبتقدروا تشوفوها بطريقة انه الكيرف داون مثل ما بدكم بتشوفوها. فهون بنقدر نقول limit as x tends to 1 minus of f of x is minus infinity. Now we have limit as x tends to minus infinity. قلنا we mean by x tends to minus infinity إنه ال x decrease to left. خلينا نشوف لما ال x عم بتروح عم تصغر لللفت. لاحظوا هون ال x decrease and we are going to left لأقصى للشمال. الاكس عم بتروح للماينس انفينيتي، وبالمقابل الكيرف approaches line of equation y equals 2. You see? So when limit as x goes to minus infinity, curve approaches what? Approaches line of equation y equals 2. So the answer is 2. And when limit as x tends to plus infinity, that means x become bigger and bigger to right of x-axis. Let's see. Here x is going to plus infinity. You see? Ex is going to plus infinity. بالمقابل الكيرف approaches line of equation y equals 2. So the answer is 2. When x tends to plus infinity, the curve also here approaches what? Approaches line of equation y equals 2. So the answer is 2. If we want the equations of asymptote, you can deduce them directly from the graph. This is the vertical asymptote of equation x equal 1, and this is the horizontal asymptote of equation y equals 2. Or you can deduce them from the limits. Limit as x tends to number, which is 1, and gives me infinity, then this number will represent for me the vertical asymptote. And when x tends to infinity and we have the answer a number 2, then this number represents for me the horizontal asymptote of equation y equals 2. Now we reach the last exercise. We have a curve of a function f of x. هيدا الكيرف اللي بالجرين هو الكيرف للفانكشن f of x، وهيدا عنا الكيرف هون، وبالنظر بنقدر نشوف انه هيدا vertical asymptote، وبنقدر نشوف انه هيدا اللاين بيمثل oblique asymptote. خلينا أول شي نبلش limit as x tends to minus 1 plus of the function f of x. شو بتعني هيدي؟ هيدي بتعني لما ال x approaches to minus 1 plus، يعني to the right of minus 1, to the right of minus 1, the curve or the values of y to where. Let's see. Here we have minus 1. لمجرد الطالب شاف انه عندي vertical asymptote، تلقائيا بيعرف انه الانسر للليمت حيكون plus or minus infinity على هيدي البوينت. minus 1 plus يعني to the right of minus 1. بنلاحظ لما الاكس approaches to minus 1 plus، بالمقابل الكيرف شو عم يعمل؟ الكيرف اذا بتلاحظوا is going down. الكيرف عم ينزل نزول. لمجرد الكيرف عم ينزل نزول بنعرف انه الانسر حيكون ماينس انفينيتي. بنقدر نقراها بهيدي الطريقة انه نشوف الكيرف داون ونقول مباشرة انه الانسر ماينس انفينيتي، وبنقدر نقولها بطريقة تانية لما الاكس ابروشز ماينس 1 بلس بنلاحظ انه الواي شو عم تعمل هون. اطلعوا على الفاليوز اوف واي، اذا شفنا الفاليوز اوف واي بنلاقيها عم تصغر وتصغر تو ريتش وات تو ريتش ماينس انفينيتي. بتقدروا تشوفوها بطريقتين. فاذا لما الكيرف لما الاكس تنس تو ماينس 1 بلس بنلاحظ انه الكيرف از جوينج داون، عشان هيك حطينا ماينس انفينيتي. وهون لما الاكس تنس تو ماينس 1 ماينس، what do we mean by minus 1 minus؟ يعني لما الاكس goes to the left of minus 1 بدنا نشوف الواي او الكيرف لوين رايحين. هيدي الماينس 1 وهيدي الماينس 1 ماينس تو ذا ليفت. بنلاحظ انه لما عندنا الاكس تنس تو ماينس 1 ماينس، الكيرف شو عم يعمل؟ الكيرف is growing up and up to reach what? to reach plus infinity. عشان هيك بنحط الانسر plus infinity. وبنقدر نقراها كمان بطريقة تانية انه الكيرف عم approaches to minus 1 minus. بالمقابل بنلاحظ انه الفاليوز للواي شو عم تعمل بهيدي المنطقة؟ الفاليوز للواي عم بتزيد. لا مجرد عم بتزيد بيكون الانسر وات؟ بيكون plus infinity. هون عم نقرا لما limit as x tends to minus infinity. what do we mean by x tends to minus infinity؟ يعني لما الاكس عم بتروح لاقصى الشمال الكيرف لوين عم بيروح؟ او الفاليوز للواي كيف عم بيكونوا؟ خلينا نشوف هون. اذا بتلاحظوا بهيدي المنطقة الاكس شو عم تعمل؟ الاكس is going to left، يعني عم تصغر وتصغر للماينس انفينيتي. بنلاحظ انه قبال كل اكس عنا هون في فاليو للواي. بتلاحظوا الفاليو للواي شو عم تعمل؟ عم بتزيد ولا عم بتقل؟ لا، الفاليوز للواي لاحظوا عم تكبر. لمجرد عم تكبر بنقول انه الانسر بلس انفينيتي. وبيقدر الطالب يقول لما نحن عم نروح لاقصى الشمال، يعني الاكس عم تصغر لاقصى الشمال، بنلاحظ انه الكيرف is going up. عشان هيك كان الانسر وات؟ كان الانسر بلس انفينيتي. here limit as x tends to plus infinity. شو بنقصد limit as x tends to plus infinity of the function f of x؟ يعني لما الاكس عم بتروح لاقصى اليمين الواي او الكيرف لوين عم بيروح؟ خلينا نشوف هون. اذا بتلاحظوا الاكس شو عم تعمل؟ الاكس عم بتروح لاقصى اليمين، عم بتزيد الاكس. لاحظنا كيف الاكس عم بتزيد؟ حنشوف شغلتين. الشغله الاولى حنلاحظ انه الكيرف is going down. لمجرد going down حنقول انه الانسر ماينس انفينيتي. وبنقدر نقول مقابل كل اكس معي هي على الكيرف عندي قبالها واي. هيدي الواي يلي عم باخدها مقابل كل اكس، بلاحظ انه الفاليو اللي لها شو عم تعمل؟ عم بتقل. لمجرد عم بتقل الانسر ماينس انفينيتي. خلينا هلا نشوف الايكويشن اوف اسيمتوت. لمجرد كان عندنا الاكس تنس تو نمبر واعطاني الانسر للليميت انفينيتي، then this number will represent the vertical asymptote. so we have x equal minus 1 is vertical asymptote. وبنقدر نشوفها مباشره من الجراف. هلا بدنا نطلع الايكويشن للاوبليك اسيمتوت. قلنا بنلاقي الايكويشن للاوبليك اسيمتوت بانه نختار نقطتين على اللاين، على الاوبليك. اللاين هيدا الاحمر اللي معي اللي مقطع. اول نقطة هي الاي عندها كوردينيت ماينس 1 and 2، وعندنا البي عندها كوردينيت 0 1. First we will find the slope. What is the rule of the slope? The slope equals y للبي minus y للA over x للبي minus x للA. الواي للبي is 1 minus الواي للA is 2 over الاكس للبي is 0 minus الاكس للA. هون عنا minus بالاكس للA وعنا minus بالرول، عشان هيك طلع عنا هون plus. so 1 minus 2 is minus 1 over 1 and the answer is minus 1. the slope is minus 1. now we can use the first way of finding the equation of this line, that is y y minus y لل a equal slope into x minus x لل a. y minus ال y لل a قد ايه عند ال y لل a؟ ال y لل a is 2 equals السلوب اللي طلع عندي minus 1 into x minus ال x لل a. عنا هون minus وعنا minus 1 عشان هيك plus 1. صار الانسر equal 1 y minus 2 equals minus x minus 1 and we will get y equals minus x minus 1 plus 2 and the answer is y equals minus x plus 1. هيك خلص معنا السؤال. شكرا لكم ويعطيكم